So everybody should be following along on the warm up. The first thing is a chart, and the chart is asking if it shows growth or decay. And so there's only one number that matters when we're looking at that. The only number that matters is the number holding up the x. So for the first one, it's 6/7. And to check a fraction, you have to look at where the bigger number is. If the bigger number is on the top, then it's a number bigger than 1. So for this one, would that be growth or decay? Is that a number bigger than 1 or less than 1? Less than 1. So 6/7, it is less than 1. So we would say that that is decay. For this one, what number holds up x? Does any number hold x up? No. By definition, an exponential has to be with x in the exponent. So this is neither. It's not an exponential. X has to be in the exponent. Okay, x has to be the exponent. What about for the last one? The only number that matters is the one holding up the x. Is 1.4 bigger or less than 1? Bigger than 1, so we would call that growth. So you need to know whether it's growth or decay by checking the number that's holding up the x and comparing it to 1. It's either less than 1 and it's decay, or it's greater than 1 and it's growth. The next question, we are rewriting. You are not solving. Rewrite. You are not solving. Rewriting, not solving. So the log ones are pretty easy. We're going to draw that little swirly thing. So it'll go like that. And we can say 8 to the second power is equal to 64. That's how we rewrite it. 8 to the second power is equal to 64. We also talked about that when you rewrite something, it has to make sense. It's going to be a true math statement. And your answer choices, if it's multiple choice, is going to be some variation of 8, 64, and 2. So don't pick 2 to the 8th power is 64, because it's not. Don't pick 64 to the second power is 8, because it's not. So be mindful when you're checking your answers. It's going to be a true statement. When we go the other direction, so the other direction from this, I know that it's going to have a log, and I know that it's going to have an equal sign. So I'm going to go the other direction where I'm going to start with the base, and the base is what's holding up that exponent. And so which number is holding up an exponent? 49. So that's where I start with the base down here, 49. And I know that I can do that little swirly thing. So it can be 49 to the something power, so 49 to the 1/2 power, so 1/2 goes over here, and then the 7 only has one spot that it can go right there. So I can double check to make sure I did it correctly by doing the swirly thing with my answer. So it would be 49 to the 1/2 power is equal to 7, and that's what I had written. 49 to the 1/2 power is equal to 7. So the swirly thing is very helpful when you're rewriting. You're not solving, you're just rewriting. That's it. What's another way to say to the 1/2 power? That's the same thing as what? We talked about this when we were expanding and condensing. What? No. What's another, how can we rewrite something to the 1/2 power? We have to do it when we expand and condense. And we wrote it on our notes. We wrote off to the side that something to the 1/2 power is the same thing as we're gonna have to do it today. We'll have to do it, so we gotta know it. This might help you if we look at the numbers. this says 49 to the 1/2 power is equal to 7. Well, how can we turn 49 into 7? Well, what would we square root? So anything to the 1/2 power is the same as square rooting it. So keep that in mind. Next question, we're going to evaluate and you have to show your work. So to evaluate these, we're going to set them equal to something. They could be equal to x. And then we're going to rewrite to solve them. So the first one becomes 10 to the x power is equal to 1,000. Anything with a 10 is pretty easy because rewriting them, how could we rewrite 1,000? And you can use your chart. How could we rewrite 1,000 so that it's a base of 10? 10 to the 3rd power. And one way that you can do that is by counting the zeros. It's going to be 10, and then however many zeros are here, that's how you know what the exponent is. And as soon as you have the bases that are the same, you can mark them off and then set the exponents equal. This one happened to show a base of 10. Do you have to show a base of 10 for log? No. What kind of log is this? What do we call it? A base of 10 is called a what kind of log? It's a question on your test. Common log. Very good. Base of 10 is a common log and you do not have to write the 10. So if you were doing a problem and there wasn't a number there, you could assume it's a 10, but it doesn't have to be written. For the next one, we're going to do the same thing. We're going to do the little swirly thing. 4 to the x power is equal to 1/16. What did I say that we could do instead of writing a fraction like this? How could we rewrite that? That's if you have something raised to a fraction power. Remember, we want to have the bases equal to each other. But having this base equal to a fraction doesn't help. How can I rewrite this so that it's not a fraction? Very good. All right, 16 to the -1 power. But I don't have like bases. Can I rewrite 16 so that it's a base of 4? So 4 to what power gives me 16? 2. And since there was already a -1 there, it will become -2. As soon as your bases are equal, you can mark them off and set the exponents equal. And anytime that you have something equal to a fraction, it's probably going to be an exponent of a negative number. For question 6, what should I do? Why? Correct. Can't take the log of a negative number. So the answer is undefined. The answer isn't 0, the answer is undefined. The next question, it says sketch the asymptote and tell me if it's growth or decay. It's written exactly the same on the test. It's not multiple choice really. For the first part, you have to actually sketch the asymptote. That is part of the points of the quiz. You have to sketch the asymptote and it's easy points. It's 4 points. 4 points of your quiz is sketching the asymptote. Sketching the asymptote. So for this one, to sketch the asymptote, it will always be horizontal. And so it'll go right here because it looks like that the graph is coming down and leveling off at 0. Oh, that one is a lot more bold than I wanted it to be. So the asymptote is right there. Please make sure that you extend past your graph so that I know that you made a line, and we should put arrows on both sides. That is sketching the asymptote. You got to do that part. It's part of the grade for this question. The next part of the question is answering whether it's growth or decay. So the way we answer this question, we're reading the graph from left to right. So from left to right, is the graph going up or down? Down. Do we think that's growth or decay? Decay. It would have to go up from left to right for it to be growth. The next question, we are expanding or condensing. So this is what I meant by anytime we see the 1/2, anything written out in front, it's going to be rewritten as an exponent. But what is an exponent of 1/2? Square root. So this will be the square root. This one will be an exponent of 3. So our first step is to rewrite. So I got log of 2. Square root of x. Alex, please pay attention, bro. You're about to take a quiz. And then from here, when you are adding, what do? Multiply. So add means you're going to multiply. So when I put these logs together, it's going to create one log. And it's the square root of x times w to the 3rd power. As soon as you can get it condensed to just one log, then you are done. That's how you know if you are done. The next problem we're going to condense as well. It's a lot of the exact same steps. What's the only difference? It's the only difference in these two problems. Subtract. So what do you do when you subtract? Divide. That's the only difference. It's still going to be a 1/2 power, which becomes a square root. It's going to be to the 3rd power. The only difference is that when we rewrite this one, it's going to be a fraction. So we get the square root of x divided by w to the 3rd power. So that's the only difference. Instead of multiplying for this one, you will divide. And remember that the first value always goes on top. And then after that, if there's anything that's adding, it will go on top. If it's subtracting, it will go on bottom. And it could have 3 things subtracting. They would all go on bottom. Could have 2 things multiplying because it would be adding. So anything that goes on the top had to be an addition. Our very last one, we have one log, so we want to expand it. This is dividing. So when you divide, you will subtract. When we split it up, so we'll start with log base 2 of the numerator minus log base 2 of the denominator. Am I done? Why not? You are done expanding, so almost, but you're done expanding when you just have one value inside. So this one has 2, so I have to expand it further. I have to expand this one further, but this one is tricky. So this is why I chose to do this one. When you have subtract, these are both on bottom. So the only way that you can say that these both go in the denominator is that both n and w, when you split it, normally you would do addition, but for this one, it's tricky. So you have to start with log base 2 of m, and then I have to subtract log base 2 of n, and I also have to subtract log base 2 of w. So I wanted to do this one as an example because they are both written on bottom. They have to both subtract. If we did this one as addition, it wouldn't work because then the w would get written on top. Does anybody have a question over why this one you have subtraction even though you're multiplying on the bottom? Anything that goes into the bottom has to be a subtract.